Hello everyone, my name is Jeevan and along with me I have my project partner Sangeeta. We represent the Department of Electrical and Electronics Engineering at Danan Sagar College of Engineering. Today we'll be walking you through our Tinkreate project, interfacing an analog joystick sensor with an Arduino Uno. To start off, what exactly is an analog joystick? At its core, it is a simple input device made of two variable resistors or potentiometers mounted at a 90-degree angle, along with a push button. As you physically move the stick, it changes the resistance along the horizontal X and vertical Y axis. The Arduino reads these voltage changes, which are typically between 0 to 5 volts, and translates them into a digital number ranging from 0 to 1023. Now I'll hand it over to my project partner Sangeeta to explain the hardware we used to build this.
Thank you, Jeevan. For our hardware setup, we kept it streamlined. We are using the Arduino Uno as our main brain to process the signals. We have the joystick module for our physical input, a breadboard to manage our temporary connections, and an 16x2 I2C LCD display to give us real-time visual feedback of our data. Moving on to the construction, the wiring is quite straightforward. The joystick sends two analog signals, so we connect the VRX and VRY pins to the Arduino's analog pins A0 and A1. The built-in switch connects to digital pin 2. To wire the LCD display efficiently, we use an I2C module connecting SDA to A4 and SCL to A5. Finally, we added a simple LED to digital pin 7. To explain how all these connections actually communicate, I'll pass it back to Jeevan.
Thanks. So, how does the system operate as a whole? When a user moves the joystick, the potentiometers act as voltage dividers. The Arduino's internal analog to digital converter or ADC grabs these continuous analog voltages and translates them into those precise 0 to 1023 integer values. The microcontroller then continuously transmits this data over the I2C protocol to print the exact X and Y coordinates on the LCD. And additionally, if you press down on the joystick, it sends a digital low signal to the Arduino, triggering the LED to blink. So next, looking briefly at the code, we first include our wire.h and liquid crystal libraries. So next, in our setup function, we initialize the LCD and declare our joystick switch as an input pull-up and LED as an output. So moving in the main loop, we use analog read to fetch the joystick's position and LCD.print to push those values to the screen. If digital read detects a button press, a simple if statement turns our LED I. Finally, Sangeeta will wrap up with the real-world applications of this tech.
First, let's see the real working of our model. While our setup is a prototype, the real-world application for this technology are vast. These sensors are heavily used in robotics and drones to control flight paths and automated arms. They act as the primary control mechanism for heavy industrial machinery like cranes and excavators. And in the medical field, they provide smooth and accessible mobility control for motorized electric wheelchairs. To conclude, this project successfully demonstrates the fundamentals of data acquisition and human-machine interfacing. By translating physical movements into digital coordinates, we can clearly see how microcontrollers process both analog and discrete signals. This basic hardware and software architecture forms the essential building block for much more complex systems proving that even simple components can effectively bridge the gap between human physical actions and digital processing. Thank you.